x bx plus ay by plus az bz is an ordinary number. It is not a vector. So here we are talking about an operation, this dot product, which is done between two vectors. The input is a and b. Those things are vectors. You multiply them. The result of this operation itself is not a vector. It's a number. Okay? Now that we have learned vectors, a number that is not a vector, an ordinary number that you've been used to since primary school, that is called just a number, or to distinguish it from a vector, it's called a scalar. Scalar just means ordinary number. No arrow, no direction, nothing, just a number like 2.95. That's a number. Okay? Negative or positive number. So the inputs into this operation, a and b, are vectors, okay, and the result is not a vector. An ordinary number, and the term for an ordinary number is a scalar. That is why we call this operation scalar product. It's a product of vectors whose result is a scalar. The result is not a vector. Is this clear? Okay? Now let us learn a little bit more about this. Let me think of the following situation. Here's my vector, well, let me give it a different name. Here's a vector that I'll call u, and here's a vector that I'll call v. And here, okay, let me suppose that u is ux in the I direction, in the x direction, uy, and uz are its components. And let me take v to be only in the x direction. Now a question to you. Okay? Tell me what is u dot v. You can discuss with your friends. I'll give you 1 minute and then I'll ask you the result. Okay, what is the answer? What do you think u dot v is? U is given, ux, uy, uz. V has only vx, the other ones are 0. So what is u dot v? Okay.
Değişmez sadece U diyebiliriz.
What is U? U is a whole vector. The answer we want has to be a number. And U dot V, let me remind you of the definition. You take the components of U and V, multiply the corresponding components. X component with X component, Y with Y, Z with Z. So in this case, what is U dot V? UX Vx, okay? Why? Because in the example I'm giving you, I chose the V vector such that its Y and Z components are both 0. Okay. Now, all right, so I know the result. Now let me look at the picture and see what this means. The length of the V vector, remember we learned last week, the length of the V vector is just, what was it? Vx squared plus Vy squared plus Vz squared. In this case, Vy and Vz are 0, so the length of the V vector is just Vx because the whole vector is lying along the x direction only. All right? So this here is Vx. What is the length of the U vector? What is the length of the U vector? Well, let me call it just U. I know how to calculate it. But the length of the U vector is not Ux or Uy or Uz. It's the whole length. It's Ux squared plus Uy squared plus Uz squared. Take the square root. Okay? So in my picture, I have this length is Vx, but this length is U. Is this clear to everyone? Now, the answer for my scalar product is U dot V in this case equals Ux Vx. Let me show on this picture what Ux is. My V vector is lying along the x-axis. So I indicated there in green, that's the x-axis, okay? My U vector is not along the x-axis. Now let me show on the picture. What is Ux? The x component of U, Ux, is the line I indicated in red. Is this clear to everyone? Now in this example, u and v are not parallel. There's an angle between them, and let me call that angle theta. This letter, Greek letter, we use a lot for angles, and it's pronounced, this thing is theta. Okay? Now, my picture shows that ux is nothing but u, the total length of this vector, times cosine theta. Okay? This is this. And what is Vx? Vx is just the x component, but because V lies along the x-axis, Vx is the full length of V. So, u dot v in this case, I've just shown, is nothing but the length of the vector u times the length of the vector v times the cosine of the angle between them. Is this clear to everyone? Okay? Does anybody have any questions about how I derived this? So what did I do? I was curious what will happen to this scalar product if one of my vectors is along one of the axes. So I said, okay, let v be just straight along the x-axis. And then I draw a picture, and I find that my definition, my general definition, ux vx plus uy vy plus uz vz, leads to the result that u times v times cosine of the angle between them is the answer I want. Is this clear? Now, I got this result by taking the x-axis along v, if I take my axis differently, does this result change? Here's a question to you. Let me make a picture, and then, so here is v, here is u, here is theta, and my axes are suppose they are like that. And my question to you is, okay, I got this formula, u dot v is the same thing as length of u times length of v times cosine of the angle between them. I got this result by doing a trick, by putting v on the x-axis. Now I change my mind. I take the x-axis somewhere else and y as the axis. None of them are along either v or u. Does my formula u dot v must equal length of u times length of v times cosine of the angle between them change? What do you think? You can look at that picture and you can discuss with your friends.